Hello everyone, and welcome to another episode of Cabinet of Curiosities on our own devices. I'm Jean Messier, and today we are having a look at a ruler. Now, I know what you're thinking. Have I already run out of interesting gadgets to review? Have I really reached the bottom of the barrel? But bear with me, because although this might look like an ordinary steel ruler from way back there, if you come in a little bit closer, you'll see that things get a little bit more interesting. So the first thing you probably noticed about this ruler is its length, 18 inches rather than the normal 12. You also probably immediately notice these weird holes punched into the ruler itself. And those are actually a clue as to the age and the intended function of this particular ruler. This is what's known as a business forms ruler, and it dates to around the 1960s or 1970s, and this is intended to help you lay out the various types of documents that you would encounter in an office environment. And these smaller holes here are for use with what's known as a line printer. This is an older type of printer that printed out on these continuous sheets of accordion folded paper that were usually printed with these green bands. And this could either be an older chain or drum printer, which is an impact style printer, or a later dot matrix printer. But in both cases, the paper was run through the printer using a set of sprocket holes. And that's what these holes are for. These are for setting out the position of sprocket holes on a business form printed out on one of these line printers. And the other larger holes right here are for afterwards. If you want to file these documents that are produced on these printers, you would punch the holes in particular locations to hang them in certain types of filing cabinets. Now, there's another scale here that's associated with printing, and it's this one where the inches are divided not into sixteenths or 32nds, but rather into tenths. And that's because these early printers had a fixed font size, and the character width was typically 1/10 of an inch. So you'd use this particular scale on the ruler to lay out text fields on whatever business form you were trying to design. Now, there's a couple of other interesting scales on here. You'll see the one where the inches are divided again, not into 16th or 32nd, but into 12ths. And this is for laying out blueprints in 1/12 scale. And this is a very convenient and often used scale because 1 inch on the blueprint equals 1 foot in the real world. And thus it's divided up into 12, so then you can actually draw inches very easily in scale. So again, all of the different types of forms that you would encounter in a business environment, particularly an engineering environment. So a couple of them are a little archaic, but still understandable from a modern point of view. But there's two scales here that are particularly mysterious. You'll notice that this one has the inches divided into increments of 150, whereas this one is divided up into blocks of 45. So what's going on here? Well, there's actually a bit of a clue printed on the ruler itself. You'll see right beside the 150 scale here that it says cards. And another clue to the use of that particular scale is the fact that this ruler belonged to somebody who was intimately involved in the introduction of computer technology to Canadian National Railways. So, in fact, this scale is meant to measure punch cards, which were an important method of data collection and data entry in the early computer age. Now, you may never have heard of a punch card, you may never have encountered one in your everyday life, but for over 100 years, punch cards were absolutely vital to information processing technology, and their history offers a very interesting insight into the early days of the information age. So punch cards actually far predate the advent of computers, and their first industrial use was actually in the textile industry. So in 1801, a French inventor named Joseph-Marie Jacquard introduced something called the Jacquard Loom, which automated the process of weaving complex textile patterns. So in a typical loom, you have two types of thread. You have the warp threads, which are stretched in parallel across the loom frame, and then you have the weft, which is attached to something called a shuttle, which is passed in between the warp threads to create cloth. So in order for this process to occur efficiently, the loom has to perform a function called shedding. And this is lifting selected warp threads to allow the shuttle and the weft thread to pass through. And this is done using devices called heddles, which are long metal rods with a loop at the end that the warp thread is passed through. Now, if you're just weaving a normal bolt of single color cloth where there's no pattern at all, then you lift up every other warp thread, and so the shuttle will pass under one, over one, under one, over one, and so on. And that was typically done by a separate employee, typically a child, known as a drawboy, who would control the heddles. Now, if you're weaving a pattern, the pattern of which warp thread is shedded from pass to pass changes. And so you have to do a lot of memorization or read off a guide, and it's very easy for a mistake to creep into the process. And so this is what Jacquard's loom was meant to automate. So the Jacquard loom wasn't an entire loom, it was a unit that mounted on top of one in which controlled the heddles using a series of punch cards. So you had these wooden cards that were punched with a pattern of holes and then chained together in a continuous loop, the length of which corresponded with how often the pattern repeated on the cloth. And these cards would be fed into a reader where metal rods would come up and press against the card. Where there wasn't a hole, the rod would stop and the heddle wouldn't lift. But if there was a hole, the rod would pass through, the heddle would lift, and that's where the shuttle would pass through. And then it would cycle to the next row in the card, the next row in the card, and then to the next card. And then when it reached the end, the pattern would repeat. And this was a lot more efficient and a lot more accurate than relying on a drawboy to actually do all of this manually. And it really revolutionized the textile industry. So a couple of years later, in the 1830s, the British polymath Charles Babbage saw Jacquard Loom in operation and realized that punch cards would be the perfect system for entering programs and data into what he called the analytical engine, which was a machine that he had designed, which, had it been completed, would have been the world's first fully programmable computer. Unfortunately, he never did finish it, and the analytical engine was only ever built as a replica by the Science Museum in London in 1991, which proved that it actually would have worked. But still, he was far ahead of his time in seeing the punch card as the perfect information transfer medium, which it would become in the early 20th century. Now, at around the same time, a gentleman named Semen Korsakov came up with a system of punch cards for storing data on criminals for the Russian Imperial Police Service, but unfortunately this really never went anywhere and didn't really spread outside of Russia. And the main use of punch cards outside of textiles for the remainder of the 19th century was actually in music, in the form of punched paper rolls for player pianos, calliopes, and other automatic instruments. And that technology was pioneered by a French inventor named Jules Carpentier in 1881. And it was the main means of automatically reproducing music before the widespread adoption of the phonograph. So the punch card really wouldn't come into its own as a medium for information collection and processing until the late 19th century. And this is in response to a major crisis faced by the United States government. Now, the US Constitution calls for a census to be taken every 10 years so that things like political representation and taxation can be adjusted according to the particular demographics of the US population at any given time. The problem was, the census of 1880 took nearly 9 years to complete. So by the time they'd finished crunching all the numbers, it was time to take another census. And they realized that since the US population was continuously growing, eventually they would reach a point where they would never be able to process it in time. They wouldn't be finished processing one census before the next one came around. Now enter a gentleman named Herman Hollerith, who had worked on the 1880 census. And the solution he came up with was, interestingly enough, inspired by a system introduced by the railroads in an attempt to catch train robbers and other criminals. Now, since photography at this time was, a very bulky, expensive process and very slow to develop photographs, the railroads introduced a system whereby a person's description could be punched into their ticket using an ordinary ticket punch. So there would be fields for things like eye color, hair color, height, whether you had facial hair, things like that. And by punching out these various fields with the ticket punch, the conductor could build up a sort of crude portrait of a person, which would help with identifying people who committed train robberies or felons on the run and things like that. And when Herman Hollerith saw this on a train, he thought, aha, well, we could use this same system to collect census data. And he went on to create not only the cards themselves, but also a very clever mechanical system for reading them and tallying up the results. And he called this a tabulator. And how this would work is that the census takers would go out and they would collect information on various households, number of people in the household, income, married or unmarried, things like that, and punch them into the card in various locations that stood for different statistical measures. These would be carried back to the census bureaus and fed into these Hollerith tabulators. So you would have a little hatch on the top that you would open and put the card in, sort of like a flatbed scanner. And when you close the lid, a series of spring-loaded pins, sort of like in the Jacquard Loom, would be forced against the card. Where there wasn't a hole, it wouldn't pass through. Where there was a hole, the pin would pass through and make contact with a bath of mercury, completing a circuit, and then the machine would tally up the information on the card. And the machine had a series of dials across its face to do the counting. And each of these dials had an outer ring that was divided into 100 segments, and then an hour and a minute hand, you could call them. So when the minute hand had completed a full sweep of 100, then the hour hand would move by one increment. And in this manner, each of the dials could count up to 9,999. Now, when this census was conducted, the machines were hardwired to collect the statistics that the Census Bureau wanted, but theoretically, you could rewire the insides of the machine and use relay logic in order to count different combinations of statistics. So say if you wanted to count unmarried males under 30, you could wire that in, and then one of the dials would actually count that every time a card had that particular combination of data points on it. And there was another device attached to the tabulator called a sorter, and it was an array of 13 vertical bins with a little spring-loaded hatch on the top. And this could also be wired up to categorize the cards in any way you wanted. So again, if you wanted to gather all the cards of unmarried males under 30, you would wire the machine to process that. And then every time you put in a card that met those criteria, the hatch on the appropriate bin would open up, and you'd take the card and put it in. And that way you would actually sort out all your data in any way you wanted. So the Hollerith system proved to be enormously successful. Whereas the 1880 census had taken 9 years to complete, the 1890 census, depending on which sources you look at, only took around 6 months to 2 years, which is an enormous improvement in efficiency. And so the Hollerith system became standard at the US Census Bureau going forward, and in 1896, Hollerith formed the Tabulating Machines Company in order to sell these machines commercially. And this type of technology in general became known as Unit Record machines, and these were the primary information processing technology until the advent of true digital computers. Now, two of Hollerith's earliest clients were the Prudential Life Insurance Company and the New York Central Railroad. And given that that railroad processed over 4 million freight waybills every year, you can imagine the advantage that the Hollerith system gave them in terms of processing efficiency. But while the Hollerith system was clever, it wasn't perfect. It had a number of drawbacks and limitations, and over the next couple of years, Hollerith introduced a number of innovations that would become standard on future unit record equipment and later computers. One of the main problems was that, as I said before, if you wanted to change how the tabulators tabulated your data, different combinations of data, you had to open up the cabinet and manually rewire it. So after a while, Hollerith introduced a plug board, which is sort of like the switchboard from a telephone exchange. So you could actually very easily rewire the machine to process the data however you wanted using relay logic. Later, it was found that in companies where they were processing different types of regimes, processing different types of data in different ways, manually rewiring a single plug board was also inefficient. So Hollerith introduced removable plug boards. You could have a number of these pre-wired however you wanted, and depending on what process you were implementing, you would take that appropriate plug board and just plug it into the machine. He also later replaced the manual one-at-a-time loading system with an automatic feed system, which increased the speed of data processing from 50 to 80 a minute for a manual operator to anywhere from 200 to 2,000 cards a minute for the automatic system, greatly increasing efficiency once more. Later, it would create a separate sorting machine. So rather than having the buckets that would open up every time you put a card in, you could wire this sorter to sort the cards however you wanted prior to processing, feed them in, and it would dump them into a number of buckets. But the main weakness of the Hollerith system was the punch cards themselves. The original cards were actually completely blank. They didn't have any markings on them to indicate where the data entry fields were and what they meant. They were meant to be read by machines and not people. And in order to fill them out, the census taker had a machine that was essentially a pantograph. You would put the blank card on one side, and then you had a little diagram of the card showing where all the data entry fields were. And you would take the stylus on one side of the pantograph and push it to the different data entry locations on the diagram. And on the other side, the stylus would punch out the corresponding locations on the card. This is very slow. This is very cumbersome. It was not the best system. So in 1906, Hollerith introduced the first modern key punch, which was basically a little typewriter with a sliding carriage. You would put your card in, and you had a series of 12 keys corresponding to the 12 rows of data entry punch locations, and it allowed you to fill out the card much more quickly. And over the years, different types of key punches would be developed, and a key puncher, somebody who actually processed punch cards for a living, became a position usually filled by women in a lot of offices that used unit record or digital computer equipment in the early 20th century. So the original Hollerith cards used in the 1890 census had 12 rows and 24 columns for punching holes, but this was later expanded to 12 rows and 45 columns. And that's what that scale on this ruler is used for, the one that goes up to 45, is to measure the standard number of columns on a Hollerith punch card. And you're probably wondering about the other scale, the one that goes up to 140, 150. That's actually for measuring the thickness of a stack of punch cards. They were punched out of standard cardstock, and so they stacked up to around 140 or 150 cards per inch. So using the ruler, you could estimate the approximate number of cards in a particular stack. Now, the dimensions of the punch cards are interesting because what Hollerith settled on as standard, which is 3 1/4 by 7 3/8 inches, was actually based on the size of US paper currency at the time, which was a little bit larger than it is today, and remained those dimensions until 1923 when it finally reverted to the current size. So despite his early success, Hollerith ran into a big problem in 1903 when the new director of the US Census Bureau, Simon North, decided that the Hollerith company had too big of a monopoly over unit record equipment and ordered Hollerith equipment banned from the US Census Bureau, and the Bureau would go on to develop its own proprietary equipment. Then, in 1911, through stock acquisition, the Tabulating Machines company was amalgamated with 4 other competing companies to form the Computing Tabulating Company. And in 1924, that company changed its name to International Business Machines, or IBM. So one of the major advancements that IBM introduced was a redesign of the punch card layout. What they realized is that if you cut the holes rectangular rather than round, you can fit a lot more of them onto a single card. And so in 1928, they introduced a new format that had 12 rows as before, but 80 columns rather than the original 45. And of course, these holes were cut as little rectangles. And this is the format that would go on to dominate the information processing industry for around the next 50 years. Now, one of the reasons that IBM was so successful was that they never actually sold anybody their machines. They were always leased. And when you consider that by 1950, IBM controlled around 90% of the punch card processing machines in the United States, you can imagine the amounts of profits they were making off of leasing the machines rather than selling them. At one point, they also considered charging for individual punch cards because they actually had a patent on that particular layout of 12 by 80 holes. and so they could become the exclusive supplier of punch cards. Unfortunately for the US government, this was going too far, and in 1932, IBM was sued by the US government for breaching the Clayton Antitrust Act. The government argued that IBM was engaging in non-competitive practices that were detrimental to the interests of their clients. IBM countered that, well, they owned the patent to the card. The card was a part of the machine, and they were providing a service, so why couldn't they charge as much as they wanted for the cards as they did for renting the machines? Unfortunately, the judgment came down against IBM, and while IBM could set the standards for how the cards were laid out, customers were now free to acquire the punch cards themselves from any source they wanted, including manufacturing them themselves. So IBM didn't manage to get that degree of stranglehold over the market, but they were nonetheless extremely successful. So IBM Unit Record equipment was used for a vast number of applications, used by companies for calculating waybills and payroll, for the census, and during the Second World War, they're also extensively used for code breaking, both in the UK at Bletchley Park, in the United States at Arlington Hall, and elsewhere, for cracking codes such as the German Enigma and Lorenz ciphers, or Japanese ciphers like Red and Purple. And what the punch card equipment was especially good at doing was comparing just vast reams of coded messages for any areas where they overlapped. And if you did find one of these overlaps, you could come up with what's known as a crib, which is a known piece of plain text that you can then use to unlock the rest of the cipher. And so it was very successful in this role, and it really helped to speed up the rate of code breaking and secure Allied victory. However, they were also put to a far more sinister use during the war. Despite the fact that IBM was an American company, like a lot of American companies, including Ford, they continued to deal with the Germans throughout the war until the US government told them to stop. And they sold a lot of unit record equipment to Nazi Germany, and they used them to process information on political prisoners and undesirables who were then rounded up and sent to concentration camps as part of the Holocaust. And this is one of the dirty secrets that IBM has to deal with to this day. So despite the fact that IBM was the dominant player in the unit record equipment and digital computer field for many decades, they didn't completely take over the market. And one of the interesting questions that's raised by the existence of this ruler is, why does a ruler that was made in the 1960s or 70s have a scale for measuring Hollerith cards as opposed to IBM cards? Didn't Hollerith cards become obsolete? Well, no, they didn't, because when IBM came onto the scene and introduced the 80-column card, a lot of companies already had Hollerith equipment, and they weren't willing to switch over to IBM. They wanted to keep their original equipment, but unfortunately IBM had a patent and exclusive rights to produce the 80-column card. Thankfully, however, somebody figured out how to use a 6-bit encoding system to make a Hollerith card store twice the information that it normally would, so that it effectively had 90 columns, a couple more than the IBM card. And in 1950, the company Remington Rand bought up Univac and started selling computers that used this new 80-column Hollerith system as a competitor to IBM. And they were quite a successful competitor because so many people had bought Hollerith machines before and weren't willing to switch over to IBM. And so a lot of companies were still using Hollerith machines, which is why rulers were produced to measure those older format cards. So by the 50s and 60s, unit record equipment was really on its way out and was being increasingly replaced by proper digital computers like IBM mainframes. But they still retained the punch cards as a means of feeding programs into the computer. This is before you had terminal interfaces. And so you would use programming languages like COBOL or Fortran, punch that into your cards to create a big stack of program, and then feed that into the card reader that would read all of your cards. If it compiled, then the program would enter the computer and you could perform whatever calculations you wanted. And so as more and more companies, as more and more organizations like universities and the government started using punch cards for everything, they became really the universal medium for information processing. punch cards became ubiquitous. They were seen everywhere, and they really entered the public consciousness, not always for the best. Now, a couple of anecdotes I've heard that are rather amusing. One comes from my father, who studied geology at McGill University in the 70s. And he remembers seeing the computer science students running around, and what they had done is they would take these old military backpacks that had the metal frame on them, cut the backpack away, and then use bungee cords to strap their boxes upon boxes of punch cards that made up their computer programs to the frames. They're running around between the computer lab and their classrooms and their dorms with these gigantic programs loaded on their back, which is rather amusing when we consider now how much information you can store on a tiny little flash drive. The other fun anecdote that I heard is from a professor of mine at university who was heavily involved in gas turbine research starting in the 1950s. And on one occasion, one of his colleagues was almost killed by one of these old IBM mainframes because his tie got caught in the card feeder and almost strangled him before the professor went and hit the emergency cutoff button and saved him. So I suppose the computer uprising started a lot earlier than most of us thought. But punch cards also acquired a rather sinister image as sort of this symbol of the dehumanizing effects of the digital age, where everybody was just a number to be processed. They weren't people anymore. And one of the memes that cropped up during this time had to do with a warning that was printed on a lot of punch cards that were issued as, say, like utility bills or things like that. And it was, "Do not fold, mutilate, or spindle." Now, folding is straightforward enough. You don't want to fold this up to put it in your pocket, because if you feed it into the card reader, it's going to jam. Mutilate also makes sense. If you tear a corner, the reader might interpret that as a hole and might cause problems. Spindle is a little bit more obscure. You might have seen this at a restaurant where you have a steel spike and then you put orders or receipts on it, and then you collect them at the end of the day. That's what spindle means, and you can imagine a system based off of reading holes. If you were to take one of these punch cards and put it on a spindle, when they fed it into the machine, it would cause absolute chaos. And because punch cards were associated with the sort of like bureaucratic, dehumanizing system, there were a lot of jokes about like, "I'm a student, please do not fold, spindle, or mutilate." And a lot of students actually burned their registration cards, which were punch cards for feeding into mainframe computers, the same way as they would burn their draft cards to protest the Vietnam War. But despite the fact that punch cards were so ubiquitous, by the 70s and 80s, you started getting like command line terminal interfaces, and the punch card just slowly died away. And now not a lot of people even know what they are. Though there are a couple of legacies. One of them is the fact that these old command line interfaces all had 80 columns, and this was to replicate the 80 columns for programming Fortran and things like that on a punch card. And there are a couple of applications of punch cards today. They're rare, but you do see them. And one of the most famous was, if you remember the 2000 US presidential election, there was the big brouhaha over hanging chads. And this is because the Florida electoral system uses punch cards as ballots. And so the problem was, if the little chad, the chip that hangs off when you punch out a hole in a punch card, if it's still there, does it count as a vote or not? And as one final little anecdote, key punches, which were used to punch out the actual holes in the punch cards, usually had a bin underneath that was known as a bit bucket or a chip bucket. And today in programming, people still refer to the bit bucket as basically a place in a computer system where information goes to die. So that's where it comes from this extremely old system that dates back to the 1890s. Now, that is an extremely broad overview of the whole history of punch cards and early computer systems. It's an absolutely vast subject that I couldn't possibly hope to cover in this short video. But I hope that gave you a nice overview of this long-forgotten technology now that was so vital to the dawn of the information age. Now, that's all I have for you today, and I'd like to give a special thanks to my friend Brendan Wakeman, who loaned me this. I'd actually never heard of these rulers before he showed me this, so I had to do quite a bit of research to figure out what it was used for, and that led me down the rabbit hole of learning about unit record equipment and early IBM mainframes and things like that. So if you want to learn more about any of these subjects, I have put a couple of links in the description of some of the sources I use for this video. Beware, it is a rabbit hole. There were tons and tons of different types of punch card equipment used. It gets very complicated, but if you're into that sort of thing, feel free to have a look at those links. Anyway, thank you for watching, and tune in next time for another episode of Cabinet of Curiosities on Our Own Devices, where we'll look at more fascinating objects just like this one. Until then, I'm Jean Messier. Have a great day.